Alright, these are 7-5 notes. This is going to be just graphing exponential functions and looking at tables of exponential functions. So for this first one, it says graph each function, find the y-intercept, and state the domain and the range. So there's 4 of them that we're going to do. So here for this first one, I'm going to go ahead and I'm going to make a table off to the side. So I'm going to do my x and y's. Okay. My x's, I'm going to go ahead and go from -2 to +4. So -2, -1, 0, 1, 2, 3, and 4. Okay, easiest way to do this, go ahead and put this into your y equals. So y equals, type in 2 to the power of x. Remember, whenever you type that in, okay, this is 2 to the power of x. It's not just 2x, it's going to look something like that when you put it in y equals. So you have to hit the caret key. When you do that, go second graph to look at your table, and we're going to fill in our y values. So my y values here, and you should be following along, are 0.25, and then I have 0.5, then I have 1, 2, 4, 8, and 16. So what I want you to notice, if you look at your table, 1 to 2, 2 to 4, 4 to 8, 8 to 16, it's doubling. Okay, so these are all doubling, so keep that in mind. Alright, so now I'm going to go ahead and graph the points that I can. So let's see, I can graph -2.25, so that's almost to the 0 line, not quite. -1.5, so -1.5, right in there somewhere. I have 0, 1, so 0, 1. 1, 2, so 1, 1, 2. 2, 4, 1, 2, 1, 2, 3, 4. So somewhere in there. And then I have 3, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So all the way up here. Okay. So now what I'm going to do is I'm going to graph this line as best as I can. So it never crosses, though, your 0. So just make sure you don't cross the x-axis. Okay. And it looks something like that. So you can hit graph if you want to double check. Make sure that you did everything right. So now what we're going to do is we're going to find the y-intercept, state the domain, and the range. So my y-intercept, okay, if you look at the graph, that's where it crosses the y-axis. So right here is where it crosses the y-axis, and that is at 0, 1. So my y-intercept is 0, 1. Okay, next thing that I need to look for is the domain. So I'm going to put D for domain. Your domain are your x values, okay? So if you notice, your arrow is going all the way up and all the way over in both directions. So my x is, that's every single number that you can think of. So I'm going to put all real numbers. So remember, it's that funny looking R. Okay, and then the last one I'm going to put is my range. So I'm going to put R for range. And my range, if you look, we did not go below this x-axis. So we did not go below the 0. So my range, all my y values are greater than 0. And if you want to go back into your table and scroll all the way up, you will notice and see that there's nothing that's negative, nothing below the 0. Okay, so there's number 1. Alright, now we're going to look at number 2. So here for number 2, okay, same thing that we did. I'm going to go ahead and type y equals 1/3 to the power of x into my calculator. So again, whenever you type that in, okay, it's going to be like this. 1 divided by 3, caret key x. It's not just 1/3 x. That's not what this says. It says to the power of x, so you have to have that caret key in there. Okay, so now we're going to do our table, our xy table. And again, I'm going to go this time, though, from -3 to +3. Okay, I'm just going to try that out. So -3, -2, -1, 0, 1, 2, and 3. Okay, look at your table, so second graph, and we're going to fill in what we know. -3 is 27, -2 is 9, -1 is 3, and then we have -1 is 3, 0 is 1, then it goes 0.33333, then it goes 0.11111, then it goes 0.037, okay, I'm just going to write 0.037, and so on. It gets smaller, smaller, and smaller, but notice it never gets below 0. So what I'm going to do is I'm going to go ahead and plot my points. Negative 327 obviously is off the chart, off the graph, so I'm not going to plot that one. Negative 2, 9, so negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the very top. Negative 1, 3, negative 1, 1, 2, 3 is right here, 0, 1 is right here, and then 1.33333, so a little bit below a half, and then it gets a little bit smaller, then it gets a little bit smaller, but notice it never, ever, ever, ever goes below 0. So I'm going to go ahead and connect my dots the best that I can. So let's go this way. Okay, and if you notice here, if you look at your y values, okay, it's divided by 3, divided by 3. It's cut in a third. Divided by 3, divided by 3, divided by 3. Okay, so that's what's happening here. These keep getting divided. All these numbers keep divided by 3. All right. And last thing that we have to do is find a little bit of information from here. The first thing that I need to do is find my y-intercept. So again, y-intercept is where it crosses the y-axis. Here's where it crosses the y-axis, right there at that point, and that still is 0, 1. Your domain will always be all real numbers. Okay, your x's will always be all real numbers because you have the arrows at the end that tell you it goes on in both directions forever and ever and ever. Your range, though, will change, but for this one, my range does not go below the x-axis. Okay, there's no negative values, which means your y is greater than 0. Okay, we got 2 more like this, so here we go, number 3. If it will let me zoom, there we go. Y is equal to 3 times 2 to the power of x. So again, type it in your calculator, go to y equals, go to your table, and we're going to go from negative 2 to positive 3 this one. So negative 2, negative 1, 0, 1, 2, and 3. Okay, my y values, I'm just matching them up with my table in my calculator. So 0.75, and then 1.5, and then I have 3, and then 6, and then 12, and 24. All right, so again, if you notice, these numbers just double, and that's my baby again, but don't worry because Daddy's taking care of her again. Your y values, if you notice going up, they just double. Okay, so 12, 20, or 6 goes to 12, double 12, you get 24. Okay, so what we're going to do is we're going to go ahead and plot these points. So I have negative 2.75, so negative 2.75 is right up here. I have negative 1, 1.5, so negative 1, 1.5. I have 0, 3, so 1, 2, 3. I have 1, 6, 1, 1, 2, 3, 4, 5, 6. And 2, 12, which that is off the chart. So I'm going to go ahead and connect my dots. Okay, remember it never crosses the x-axis, but it gets pretty low. Very, very close, but never crosses it. Okay, and now what we're going to do is we're going to answer 3 questions. So the first one is the y-intercept. Okay, so your y-intercept, again, is where it crosses the y-axis. It crosses it up here. And that is at 3. So my y-intercept is at 0, 3. Okay, then again, my domain, your arrows are going in both directions, so my domain is all real numbers, so it's every x value is included. And my range, again, so my range, if you notice, none of these values go below 0, so y is greater than 0. And that's it, okay? We got one more we have to do, number 4. So I'm going to do my table on this other side for number 4. So number 4, we have an xy table, okay? I'm going to go from negative 3 to positive 4. Just kind of want to see what's going on here. Okay, so negative 3 to positive 4. So negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. And then just go ahead and type this in your calculator. Go to your table. So put that in y equals, go to your table. And my y values, okay, just copying from the table, are 2.03, and then 2.11, and then 2.33, and then 3, and then 5, 11, 29, and 83. I'm about to have to go take care of baby. All right. So I'm gonna go ahead and plot these points real quick. We have. Let me get my orange. Negative 1, 2, 3, 1, 2, a little bit above 2. Negative 2, a little bit above 2 again. A little bit above 2 for negative 1. 0 is at 3, so 1, 2, 3. 1 is at 5, so 1, 2, 3, 4, 5. 2 is at 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That's way off, like up here. So that's 9, 10, 11 will be like somewhere up here. Okay, connect the dots. So it gets really close to 2 but never crosses. Goes all the way up. Okay, and now let me figure out, I'm going to zoom back out over here. Okay, so now I'm going to go ahead and do my y-intercept. So y-intercept is where it crosses the y-axis. So if you look across the y-axis here at 1, 2, 3, at 0, 3. So at 0, 3. And then my domain, again, are all my x values. So I include every x value, so I have arrows on both sides, so it's all real numbers. And then the last one is my range. Okay, and if you look, my range here, I don't go below this line. And I'll do it, highlight it so you can see it. I don't go right below this line right here. That line right there is at 1, 2. So my range, or all my y values, are greater than 2. And you can look, okay, right here in your table, notice you're getting really, really close to 2. If you keep going up in your table, in your calculator, you get really, really close to 2, but you never reach it. Okay, so you can pause, and you're going to have to fast forward this little part because I got to make sure my baby's okay. So hang on 1 second. Hey, do you need my help? Okay, just want to check because I'm still doing my video. Okay, just have a hungry baby. All right, so now let's go to these last 4 real quick. Okay, so last 4. And all we have to do is say whether or not this is an exponential behavior. It says write yes or no and explain yes or no. Well, the explaining part is going to be in our work. Okay, so let's look at my x values for number 5. Okay, so for my x values, I'm going to do my little arrows so I can see what we're going up by. My x values here, they are going up by 1. So I'm going to put plus 1, plus 1, plus 1, plus 1. Okay. Down here on the bottom, I'm going to do my little arrows. And this is going 9 to 12, you add 3. 12 to 15, you add 3. 15 to 18, you add 3. Now remember, our exponentials in the other ones, it was like either doubling or it was tripling or it was being cut in half or cut by thirds or, it's something that happens like that. Here, you're just adding 3 every single time. Nothing is happening to these numbers. 9 to 12, 12 to 15, 15 to 18. Okay, you're just going up by 3s. So this, it's not exponential. We're going to put here no. This is actually linear. So it's linear. And how do you know it's linear? You have a constant rate of change. All right, number 6. Okay, so number 6, again, we're going to go ahead and look at our x values, what we're going up by. So here we're going up by 5 every single time. Okay, and then in my y values, all right, if you notice in my y values, if I were to look at the difference, here I'm subtracting 10, here I'm subtracting 5, and then here I'm subtracting 2.5. Okay, this is where you got to kind of notice your numbers. Okay, so let's look at this 20 and 10. Okay, so I'm looking at my 20 and I'm looking at my 10. That was cut into half. 10 and 5, that's cut in half. 5 and 2.5, that's cutting 5 into cutting 5 and a half. So you can plot this if you want to. If you want to pull up the notes on Schoology that I already filled out, I have the graph on there. Okay, but yes, this is going to be exponential. Because if you look at the pattern with your x values are going up by a constant number, that's okay. Your y values, though, are being cut in half. And so when they're like being cut in half or they're doubling or cut in thirds, like I said, that's how you know that it is going to be exponential. All right, we got 2 more. So x here. Okay, so my x values, again, I'm going up by 4, going up by 4, going up by 4. Okay, so that part's good. My y values, here I'm going up by 20, then I go up by 40, and then I go up by 80. So this is not a constant rate of change, so it's not linear. Okay, but let's look at these y values again. So if you're looking at your y values, you're going from 20 to 40. So what's happening? Well, that doubled. 40 to 80, it doubled. 80 to 160, it doubled. So again, this is exponential because it is doubling. Doubling, halving, tripling, okay, those are all exponential. So last one, let's see what's happening here. So for my x values, okay, subtracting 20, subtracting 20, subtracting 20. And then for my y values, subtracting 20, subtracting 20, subtracting 20. So again, looking at my y values, I can tell 90 to 70, 70, 50, 50 to 30. This is not exponential. This is linear. And again, it's because you have a constant, a constant rate of change. So let me finish with that. Constant rate of change. Alright, and that right there is your 7-5 notes. Okay, I'm sorry again about the little baby crying in the middle of it. Alright, so if you need any help, just let me know.